right, folks, this is a first video introducing the concept of adding rational expressions. And in order to understand how to add rational expressions, we're going to revisit the idea of adding fractions. Now, when we add fractions, the rule, our rule of thumb, is that the denominators have to be equal in value. In other words, they're identical numbers. Once we are able to make that happen, then we add the numerators. Through the process of manipulating our denominators, whatever we do to the denominator, we have to multiply the numerator because we do not want to change our final outcome. All we want to do is sort of change the appearance of these fractions, right? And that idea is going to be applied to rational expressions. Okay, so I'm going to quickly just go over a couple of these, and then I'll make a few more videos on just focusing on rational expressions using the same idea. Okay, in this case, what we're going to do is we're going to multiply 4 and 3. Okay, when I do that, I'm going to rewrite it over here. That means I multiply the denominator by 4. That means I have to multiply the numerator by 3. So 4 times 3 and 1 times 3. And technically what I'm doing is 3 divided by 3 is 1. So I'm multiplying by 1. But as you will see, it helps you manipulate the appearance of this expression, but it still maintains the original outcome, the result, right? Plus 2/3. This will be multiplied by 4, multiplied by 4. And what are we left with? We're left with 3 over 12 plus 2 times 4 is 8 over 12. So here's the work. My denominators are identical, they're equal. Now I can go ahead and add the numerators. So this is going to imply that 3 plus 8 divided by 12, I rewrite my final expression, 11 over 12. If I could simplify, I would do it. Since I can't, I am done. Okay? That's the basic concept we're going to use. Now, let's take the same problem. Let's say 1 over 4 plus 3 over x. So now we have a rational expression because my denominator here is x. Now I know x can't equal what number? 0, because then it makes this undefined, then this becomes a mess. So I need to add these two rational expressions. They must have identical denominators or equal denominators. So what am I going to do? I'm going to multiply the numerator and denominator by this term. And I'm going to multiply this denominator by this term right here. I rewrite my answer. I have 1x divided by 4 times x plus 3 times 4 is 12 divided by 4x. Now notice that my denominators are identical. So now I can go ahead and access the numerators and add them. So I'm left with 1x, I'm going to remove the 1, x plus 12 divided by 4x. Word of caution, don't try to divide out 12 by 4. This is one expression, so what I would recommend is you do this, because then that'll help you understand, like, oh, 4 can't divide into 12. 4 times x has to divide into the group of x plus 12. And that'll keep you from making that mistake that many students like to do, which is divide 12 and 4, right? They'll do this, and then they say this is 1 and that's 3. No, that's not. Can't do that. Why? Very simply by having the parentheses, and I'll put 12 in purple, parentheses in here, that kind of brings you back to the rule of thumb of PEMDAS, right? Can I divide 4 times x into 12? No, I have to divide it into the group that's within the parentheses, which is x plus 12. And since I can't simplify any further, then write down x cannot equal 0. And I am done. One last one, just to kind of show you different variations. Let's say we have 2x divided by y plus 8 divided by 2x. Okay. Now, first thing you're probably going to want to do is simplify across. Remember, we're not multiplying, we're adding. So we have to be careful with that. Let me make that 8 a little bit better. So again, are the denominators identical? No, they're not. So I multiply across. And now I'm going to use a little bit of color. This term, y, is multiplied by this term, 2x. That means the numerator has to be multiplied by 2x. Same can be said for 2x. It's going to be multiplied by the term y. That means the numerator, 8, is multiplied by the term y. And when I do that, I'm going to be given a new expression. Doesn't change my answer, my outcome, but it does change the appearance of my rational expression. 2x times 2x is 4x squared divided by 2 times xy plus 8y divided by 2 times xy. These are identical. Now I can go ahead and add my numerators. So I'm left with, notice that my denominator now is just 2 times xy. I don't add these and get 4xy. What I'm saying is because they're identical, I can rewrite it in this way and just add the numerators, which I have 4x squared plus 8x. Oops. Now, some of you might stop here and say, well, okay, I'm done. Careful. Remember I said put this in parentheses? Can I factor things out of here? Yes, I can. What am I going to factor? Think about it. Pause the video if you like for about 30 seconds and think about what can I factor out and what would my expression look like? Take the time now. Okay, so if you're paused and came back to it, you should be able to factor out 4x. So I'm left with 4x. So 4x squared divided by 4x is going to be x plus 8x divided by 4x is 2. Okay, divided by 2 times x times y. Now, in this case, because I have a group here, but I'm also multiplying it with 4x, I notice now that this 2 and this 4 share something in common, factor of 2. So I can simplify this by dividing both the numerator and denominator by 2. I'm left with 1, and this would be 2. I also notice x here and x here, that's another 1. Okay. The reason I can do that is because this group is multiplying with that group, and so I can apply it here. I can't apply it here because it's the sum of the terms, okay? So my final answer is going to be, and it's just going to be 2x plus 4 over y. And right here at the bottom, x cannot equal 0, y cannot equal 0. There is my final answer. And that's an introduction to adding rational expressions.